This is Geometry, Semester 2, Midterm Review. This is video number 3. We're looking for the value of x and y. Here we see we have our angle on the edge of the circle. It opens up and it touches at the 98 and the 43. So we have 141 degrees. So we know this inscribed angle is going to equal half of the measure of the intercepted arc. So that means that here at x is going to equal half of 43. The intercepted arc is from M out to K. So half of 141. So that means x is going to be 70.5 degrees. Now we have the value of y. This is in quadrilateral, so opposite angles have to be supplementary. If a quadrilateral is inscribed in a circle, then opposite angles are supplementary. So we're going to have y plus 114 equaling 180. So y is going to be 66. So y is 66 and x would have to be 70.5. Here for number 24, if I'm looking for x, I don't have the opposite angle, but I do have an inscribed angle that equals half of the intercepted arc. So x is going to equal half. Notice how it touches out here at h, it touches up here at f, so it's going to be half of 108 and 75. So x is going to be half of 183. So when you take half of that, you get 91.5 degrees. And then y, angle y, is half of its intercepted arc, so it touches out here at E, and it works its way all the way until you get to G. You always go the direction that the angle opens up to. It's called the intercepted arc. So angle y equals half of 108 plus 110. So angle y is going to be 109. Here we're looking for the measure of BAC. You could also call that angle A. The measure of angle A, it's an inscribed angle because the vertex is on the edge of the circle. the inscribed angle equals half the measure of the intercepted arc. So the measure of angle BAC is going to equal half of the measure of arc BC. That's the way you would write it with the letters. So the measure of angle BAC equals half of 158. So that should be 79. Here we're looking for the measure of angle BAC. So we're looking for this angle here and arc ADC. Well, I see that ADC is connecting the endpoints of the diameter together. So I know that's a semicircle. So I know the measure of arc ADC equals 180. Now, if it's 180 on this side, then I know it's 180 on the other side of the diameter, because it's 360 for the whole circle. So if we have 180 over there, part of it is 73. That gives me that BC. So the measure of arc AB plus the measure of arc BC has to also be equal to 180. AB is 73. So we're going to subtract the 73 across, and that's going to give us the measure of arc BC is 107. That adds up to 180. So if this is 107, then we know the intercepted, or the inscribed angle equals half of the intercepted arc. The measure of angle A equals half of the measure of arc BC. Measure of angle A equals half of 107. For number 27, this is called a circumscribed angle. The circumscribed angle equals half the difference of the two related arcs. So what that means, if we're 110 here, we know it's 360 around the whole circle, so 360 minus the 110 gives you 250. So it's 250 all the way around from PQR. Plus the 110, that's what gives you your 360. So the measure of angle T equals half the small, well, we'll take the big arc, the measure of PQR, minus the small arc, PR. So the big arc minus the small arc, half the difference of our two related arcs. These are called tangent rays. They intersect outside the circle, and they split the circle into two parts. Never can it split it into 180 and 180. So the measure of the angle equals half of 250 minus 110. So the measure of angle T equals half of 140. So that's going to equal 70 degrees. Number 28. We're going to find the indicated measure. We're looking for the arc length of arc AB. So what a lot of people confuse here is with arc measure. Arc measure is going to be the same as the intercept, this is an inscribed angle. It's going to be the same as the inside angle for the measure, but this is length. This is the actual, how many meters long is this supposed to be? This is not 88 degrees. We're looking for a meter's length. So to do that, we're going to take arc length over the circumference is going to equal the central angle over 360. So what this is saying is the arc length to the circumference. The arc length is part of the whole thing, just like the angle of 88 is part of the 360. So AB with a curve around it, length arc AB, it's not the measure, so we don't put an M, over circumference, which is 2 pi r, is going to be our 88 over 360. So the length of our arc over 2 pi times 2, because that's a radius, so our unknown value we could call x if we wanted to, and we'll have 4 pi equals 88 over 360, and we would cross multiply that way. So we'll say 88 times 4 times pi. And then we're going to divide that by 360. So we're going to get 3.07. Okay, so that is the length of AB. This time we know what the length of AB is, or this is really RS, but we know the length of the arc, we know the radius. What we don't know is this central angle. So we're going to use the same formula, same proportion. We have arc length over circumference central angle, that's what we're going to be looking for, over 360. This is when we're working with arc length. So we know the 38 part, because that's the arc length. We know the radius, What we don't know is the central angle. We'll call x over 360. So we'll cross multiply. Now I'm not cross multiplying up to the x because I want to keep the x by itself. Same reason I didn't do it over here. So I'm going to take the 38 and times that to 360, and then I'm going to divide this. Now, to divide this correctly, you need to be sure to use parentheses. 2 times pi times 12.3. You've got to use parentheses if you're going to represent dividing by that whole denominator. So the measure of angle RQS equals 177.01 degrees. And when we look up here, we see that this is well over 90 degrees and it's almost a straight line. So 177 seems reasonable. Now what we're trying to figure out is the shaded portion. It's called a sector, the area of the sector. So we're going to take the sector area over the circle area equals the central angle over 360. So what this is saying is that the portion that we are looking for in terms of the area to the whole circle is just like the angle 63 is to the whole 360. We don't know the sector area, but the area of the circle is pi r squared. The central angle is 63 over 360. So I'm going to cross multiply. I have 63 times pi times 25, because 5 squared is 25. Get a real big number, divide that by our 360. Notice I didn't cross multiply this way because I don't want to multiply things with the x. I want to get things away from the x, so I didn't take time to bring that up because I'd be dividing it away. So 13.74. And it doesn't give us units here, so we just say units squared because it is an area. So here again, we don't know what the sector area is. Looking for sector area over circle area equals our central angle over 360. Well, our sector area will be our x. Our circle area is pi r squared, 106 over 360. We'll cross multiply and divide by the 360. So the 106 times pi times 9 squared. 9 squared is 81. So we get this really big number, and we're going to divide that by 360. So x is going to equal 74.93 feet squared, because feet are the units. So here we know what the area of the sector is. We're looking for the area of the circle. So we're going to use the same proportion, but now we're solving for a different portion of it. With both of these, sector area over circle area equals our central angle over 360. Well, our sector area in this case is 36.07 centimeters squared. They're telling us it's the area of our shaded region over the area of the circle. So we can just put over the area. We don't want to put C because C typically stands for circumference. Angle is 58 over 360. We want to solve, we call it X, I guess, but we want to solve for the area. So in this case, we do need to cross multiply it because right now it's on the bottom. We've got to bring it up to the top. And we're going to multiply this way also. So we're going to take our 360 and times it to the 3607. That gives us 12,985.2. And then we're going to divide that by 58. So we'll write this out. When we multiply here, we get 12,985.2 equals 58 times the area of our circle. We divided that by 58. Here's how we show our work. 223.88. This is an area, remember, so it's centimeters, that's our units, squared because it's area. And that's the area of our circle. On this one, they're not necessarily looking for the area of the circle, but they're looking for the diameter of the circle. So we've got to take the area, which is pi r squared, figure out what r is, and then double that to figure out the diameter. So this has got a couple steps. It's going to be a bit tricky to work with. So we're going to start out with the same formula. So we're going to start out with the sector area. There's our sector area. So we have 72.39. The area of our circle is pi r squared. Our angle, well, if it's 109 on this side, our sector is really over here on this side. So what's going to be the central angle for the portion that we're actually interested in? .360 minus the 109 gives us 251. 251 is the degree value out here. So 251 over 360. It's important not to use the 109. So we'll cross multiply. .39 times 360. That gives us 26,060.4 times 251 pi r squared. So we'll divide this number by 251 to get 103.83. We divide it by the 251. Now we have to divide by the pi. So divide by pi. That leaves us with 3305. And then how do we get the r squared out of there so it's just r? We need to take the square root of our answer. Be sure to use answer. Keep the running answer throughout the whole problem. Don't be putting in rounded numbers. So the radius is going to be 5.75. That's r. So the diameter equals 2 times 5.75. So the diameter is going to equal 11.50. And these would be feet. Look at what we did. We first started with the same proportion. Essentially, we solved for area. And then we took the area and we divided that by pi and took the square root to get the r by itself, so we could then find the diameter. Because diameter is twice the radius. This is the last page of our midterm review for semester number 2. You and your friends build a ramp for a construction company. The length of the ramp needs to be 18 feet. So it needs to be 18 feet. The ramp covers a horizontal distance of 12 feet. We know that the legs of a right triangle are shorter than the hypotenuse, so that seems reasonable. But now what we need to figure out is, what is this angle? There's a variable we can use called theta to represent that. You can name it a letter if you wanted to. We're going to use SOHCAHTOA to help us determine which trig function we're going to use. Across from the 90 is considered the hypotenuse. Across from the angle that we're working with is opposite. Next to the leg next to the angle we're working with is the adjacent side. So if you notice here, we know about the adjacent, we know about the hypotenuse. We don't know anything about the opposite. We're not looking for the opposite. We're looking for the angle of elevation. From a horizontal, that's the angle that looks upwards, angle of elevation. So we're doing adjacent over hypotenuse, which is cosine. So cosine of our theta equals the adjacent over the hypotenuse. You can reduce that if you like. To get the theta, or the angle, all by itself, we're going to move the cosine over. To move the cosine over, we need to use cosine inverse of 12 over 18. Be sure you're in degree mode. Cosine inverse of 12 divided by 18. That gives us 48.19. Those are in degrees. You need to get your wheelbarrow onto the back of your truck. You've researched and found that the typical angle of elevation for such a ramp is 25 degrees. If you plan to use a 16-foot 4x4 posts as the actual ramp, okay, so we're using this 4x4, or maybe more than one of those. We're going to try to go up 25 degrees. then what is the horizontal distance your ramp covers? What is the horizontal that our ramp covers, which would be x? So we know that we're using 16-foot boards, and that would be your hypotenuse. This would be your adjacent side, just like the previous question. So thinking about SOHCAHTOA, that helps us determine which trig function we're going to use. Adjacent over hypotenuse. So cosine of 25 degrees equals the adjacent side over the hypotenuse. Put it over 1 to cross multiply. So we get 16 times the cosine of 25 equals our x. So we get 14.5. And the units for that would be feet. The quadrilateral is a square. Find the area of this shaded region. So this is just a portion of our square. And it looks like our circle is going to have a radius of 6 centimeters. So what we're going to do, we're going to figure out the area of 1/4 of the whole circle. And then we're going to work with our area of our square. There won't be any need for any subtracting here because we're not dealing with the outside portion. That could be another question. But we see that our radius equals 6 centimeters. So the area of a circle is pi r squared. So the area of this circle is pi 6 squared. So we typically call that 36 pi. That's the whole thing. But our central angle here is 90 degrees. So it's 1/4 of the total amount. You could use the formula to figure out the sector area and just use 90. We're looking for sector area over circle area equals angle over 360. The result here is going to be the same thing as if you just divided this by 4. But the sector area is what we don't know. The circle area is 36 pi. The angle here would be 90 because it's the corner of our square. Over 360. So I'll cross multiply, but I won't bring the 360 up towards the x. I'll just bring the 36 pi. So we're going to take 90 times 36 times pi and divide that by 360, and we're going to get 28.27. And those would be centimeters squared. Now what I'm assuming here is if we took our 36 times pi and we divided that into 4 equal pieces, essentially we get the exact same answer. Just a different way to solve it. This is a way that we've talked about in class. using our sector area. But if we're using 90 degrees, that is breaking this circle into 4 equal pieces, so it makes sense to divide it by 4. If this happened to be 30 degrees or 52 degrees, this formula would most definitely be needed. Our last question. This question didn't quite come out the way I think it was supposed to. The square has a side length of 12. So again, we have a square, 12, and if it's a square, then the other side is also 12. Find the area of the darkest shaded region. It's the portion not in the circles. Right now it looks like this portion is in the circles, but we're going to work on just figuring out the portion down here and the portion up there. That's really what it was expected to do. But I'll explain how we could find the other one also. So what we're going to do, we're going to take the entire square, which is 12 by 12, and then we're going to subtract out half the area for this circle and half the area of that circle, if we wanted just the top and the bottom. We have the area of the square minus 2 half circle areas. So the area of the square is 12 times 12. Our circle has a diameter 12, so a radius of 6. So we're going to do 2 of the half circles, pi r squared. So we get 144 here. You could say that half of 2 and cross those out completely, but we'll leave them there for a second. Our radius is 6. Square that. You can't take half the 6. Pi times 36. Now you could take half of the 36 if you wish. So we get 18 pi, and when we times it by 2, oh, I'm sorry, I'm putting equal signs in here. I got confused there for a moment. We're not equaling them, we are subtracting them. Subtracting 36 pi. So we're going to take 144 and minus this 36 pi. Let me be sure that that came out right. 144 minus this whole quantity of 36 times pi. And of course that worked out just fine. So we have 30.90. And those are in feet, and its area, so it's squared. If we were going to find just all the dark area, if that's the portion that you thought you were supposed to find, because that's the way the picture looks, then you would take your 144, which is your whole circle, and you would minus half of a circle, half of the pi times 36. That would make it a little bit bigger. there would be more area covered. We subtracted 2 times that amount. And we got 30.9. So however you solved it is fine. The intention was the 30.90.